Hello everyone! In the previous lesson we talked about retention, a metric that helps us understand how long user stays with our product. But there is an important question. Do those users actually generate revenue? You can have excellent retention and still lose money. That's why today we'll focus on LTV, lifetime value, the total value a customer brings to the business over their lifetime. In this lesson, we'll go through the entire journey from naive LTV to a cohort-based model, to a retention and LTV matrix, and even to LTV forecasting. And we'll do all of this using data that is very close to real production data. Why LTV matters? LTV is one of the key business metrics. There is another important metric called customer acquisition cost, CAC, the cost of acquiring a new customer. If LTV is greater than CAC, the business is profitable. If LTV is lower than the acquisition cost, every new customer generates a loss. This is the foundation of unit economics. So let's start by generating our dataset. First, users. We'll create a table with 1,000 users, not bots. We'll distribute them across 4 months. This will be our cohorts. Why 4? Because 2 would be boring and 12 would take too long to calculate. Now let's move on to orders. First we create the table and then we generate the data. Each order will have an order date within 120 days after registration. Revenue randomly generated in the range from $20 to $1,500. Cost, which is 40 to till 80% of revenue, and 10% of orders will be refunded. Because a perfect business doesn't exist. If your dataset shows 0% refund, then either you are Amazon or your data is incorrect. We also simulate real user behavior. Each user makes between 1 and 10 orders, just like in real life. Some users come once and never return, while others become our favorite power users. Now our datasets are ready. As before, all scripts and additional exercises will be available in the Practical SQL repository, and I'll leave the link in the description below the video. Let's start with the simplest version of LTV. In this calculation, we ignore refunds. Profit is revenue minus cost, and a very common mistake is calculating revenue instead of profit. We then group the results by user ID, and here we go, our champions. But there is a small problem. This calculation completely ignores time. A user might generate 1,000 in 3 years or 1,000 in 3 days. For the business, that's a huge difference. So let's add the time dimension and move to a slightly more advanced calculation and add the time factor. Imagine that January advertising was extremely effective while March campaigns wasted the budget. If we don't break the data down into cohorts, we simply won't see this. Now we group not only by user ID, but also by registration month. Great! Now alongside LTV, we also have the cohort month, the user's registration month. This already gives us more insight. But businesses rarely focus on user-level metrics. They prefer aggregated averages, especially investors. So, the next step is to calculate the average LTV per cohort. This is already a strategic metric. This is the metric that gets compared to customer acquisition cost. And this is the metric that answers the question, are we actually making money? But there is still another problem. Revenue doesn't arrive all at once. It is distributed over time. It's also worth mentioning that in the repository for this course, you will find not only monthly versions of the scripts but also weekly ones. For example, if you need more granular analytics, such as for products with short user life cycles or highly transactional business models, you can use the weekly cohort scripts. They follow exactly the same logic. The only difference is the level of aggregation. Instead of months, we use weeks. This allows you to analyze LTV dynamics, cohort behavior, monetization speed. All the corresponding SQL queries are available in the repository. You can run them directly or adapt them for your own tasks. This way you can choose the level of detail depending on your business context. Now, we move on to building a retention and LTV matrix. This is where things get really interesting. In this script, we perform cohort analysis that shows how users return and how much revenue they generate. First, we determine the cohort size, how many users registered in each month. This is important because this number becomes the denominator when calculating both retention and cohort revenue metrics. Next, we split users by their lifetime months. Month 0, registration month. Month 1, first month after registration. Month 2, second month of the user life cycle, and so on. For each cohort and each lifetime month, we calculate retained users, how many users returned and placed an order, retention rate, the share of returning users relative to the cohort size, the total number of users in the cohort, cohort revenue, total revenue generated by the cohort, LTV, the average revenue per user. Let's run the script. The result is a table where rows represent cohort months, columns represent lifetime months, cells contain user behavior and their average value. This is what real production analytics looks like. Here you can clearly see where the business is thriving and where it is slowly dying. If retention drops quickly, LTV won't save you. The math is ruthless. This table allows us to build heat maps, analyze cohort decay, and identify which cohorts generate the most value. In other words, we analyze both behavior and financial metrics of cohorts at the same time, which makes it extremely useful for product and marketing decisions. But businesses don't live in the past. They live in the future. So now we will calculate forecasted LTV. Here's how the script works. First, we take each user and determine their cohort, meaning the registration month. Next, we determine the lifetime month, how many months have passed since registration. Then we calculate user profit. Profit equals revenue minus cost, but only for non-refunded orders. Next, we aggregate the data and calculate cumulative LTV, the total profit generated by all users in the cohort. Then we calculate the average LTV per user by dividing by the cohort size. Finally, we compute forecasted LTV. Here we apply a decay function using x minus 0.1 multiple lifetime month. This helps account for the fact that user activity decreases over time. For forecasting, there are different approaches. You can apply decay models or extrapolation. In production environments, companies often use machine learning models or survival analysis. But the logic always starts here with understanding lifetime dynamics and how profit is distributed across lifetime months within a cohort. The final table includes cohort registration month, user lifetime month, total cohort profit, average LTV per user, and forecasted LTV based on decay. In other words, we get a dynamic view of cohort revenue across lifetime months with both actual and predicted user value. Summary. So today we went through the full journey, calculated naive LTV, moved to cohort-based LTV, calculated average cohort LTV, built a retention with LTV Matrix, and finally implemented a forecasting model. That's all for today. If you enjoyed this video, subscribe to the channel so you don't miss new breakdowns and practical insights. Follow the updates, solve the exercises from the repository, and keep practicing. Leave a like, write your comments, share your ideas, and thank you for watching. See you in the next videos. Bye for now.